Hello, Mrs. Les.
Hello, Mr. Miller.
It's time for a couple more examples of proving triangles are congruent. So this is video number 36. Get your journals ready. And we're going to do 2 examples, and we have an assignment for you. So this is Triangle Congruence Proofs. All right. So for our first example, here we go, a little trouble. So for our first example, let's take a look at the figure. We're given that AB is parallel to ED. And if information isn't marked, I kind of like to mark it. So I'm going to put little arrows on those to show that they're parallel. Okay, so we got that going for us. And AC is congruent to EC. That's already marked. So the first step is to kind of come up with a game plan. How are we going to show these are congruent? So what shortcut are we going to use? Well, we may need these vertical angles. We got those 2 angles going.
Okay, very
so we got matching angles, matching side. And because these are parallel, see the Z shape? We have that this angle and this one are alternate interior.
Excellent.
We got a matching set of angle, side and angle. That's the game plan. All right, so now that we kind of came up with the plan and analyzed the figure, we just got to write it down. So I'm going to start with the givens. AB is parallel to ED. I like the givens, Mrs. Les. And I'm going to squeeze another one in there, so I'll put it like a semicolon or something. And we have AC is congruent to EC. You can use 2 lines for the givens, that's okay. I wasn't sure if I can get this all done in 4, so I just combined them. Those are both given. All right, so now I gotta take care of the fact that these 2 angles are congruent. So we have angle ACB is congruent to angle ECD. And the reason why is less
vertical angles
are
congruent.
So I'm going to abbreviate VA.
Okay.
R. And then I'm going to get real lazy because I hate writing. How's that for shorthand?
Wonderful.
Vertical angles are congruent. Is that okay to do that?
Good.
As long as we're clear, state the reason clearly. All right, so part of the given was that these 2 sides are congruent, so we got that taken care of. We got these 2 angles together. Now I have to take care of angle A and angle E. So angle A is congruent to angle E because, are you ready for this? Alternate. There's less scream if I'm abbreviating too much. Interior angles. How about that for angles?
Angles, awesome.
Am I pushing it?
No, I think we're good with that.
I
think by now everybody knows all these symbols.
Congruent. All right,
awesome.
Cool. Now, so we did it. We got the 2 sets of matching angles and the side in between. So I already know that this is going to be angle, side, angle. And I just got to be careful. Oh, actually the congruence statement's right there. The last statement should be what we were trying to prove. So we made it there. Triangle ABC is without a doubt congruent to triangle EDC because of the angle, side, angle.
Awesome.
All right. Okay, we got a little bit more complicated one for you. Ms. Les?
Okay, let's see if I can handle that.
Have fun.
Okay, so for example 2, so again I'm going to take a look at the example and see what's given to me here and what is my plan. So I know AB, which is this side right here, it's not marked, so I'm going to mark it. So AB is congruent to DB, so these 2 sides are congruent. I also have these 2 angles, right angles, so they're always congruent, 90 degrees. So I have a side and an angle, so I need something else. I see this side right here.
Very tempting.
Yes, but that's not really going to help me, right? Because I would end up with side, angle, which I can't use.
Right.
But if I know that these 2 sides are congruent, what can I conclude, Mr. Miller?
Oh, triangle ABD is an isosceles triangle.
Absolutely.
And the base angles are congruent. And the only reason why I know that is Ms. Les told me before we started making the video.
So these 2 angles, angle A and angle D, are base angles, so they are congruent. So I have side, angle, angle, or angle, angle, side.
Now, for really sharp students, if they've seen some proofs before, isn't there something called a hypotenuse leg? theorem that if you show a hypotenuse and a leg of a right
Yes,
triangle
for
are
right
congruent,
triangle.
you could
We
do
can
it.
prove it congruent.
So in this case, the middle side maybe, but we're not going to worry about that too much. We're going to stick to like angle, side, and the basic ones.
Okay.
All right,
awesome.
so maybe you heard about that, or you hear about that sometime. But
So-
we don't need that.
AB, my first statement,
Well, let's start with the givens.
is congruent to DB. Okay, so that's given. Then I have this angle right here, right angle. So remember to use 3 letters, angle ACB. Vertex goes in the middle, is congruent to angle DCB. Okay, so these are right angles. Let's put angles. So some more symbols.
Very good. Right angles are congruent.
Then, my third piece of information, angle A, is congruent to angle D by the base angles.
So in class,
So let's put
If we
base
haven't
angles
yet-
theorem.
we'll give out a reference sheet. It's very helpful. It has like a list of reasons we can use, valid reasons.
Yeah, so you
Okay.
can just find that on the list.
Right.
Will be one of the reasons. So I have my 3 things, angle, and side, so I can conclude triangle ABC is congruent to triangle DBC, and the reason is angle, side. We're done.
How about that? You start with your given, logically, step by step, show why we can conclude what we're supposed to prove. All right.
So I think you're ready for your journal.
It is. Okay. This was pretty quick this time. So I want you to copy the problem. So copy the given and the proof and the diagram, and then supply the missing reasons. So we gave the statements. So you have to explain why each statement is true.
Okay, so a little bit easier. You don't have to do everything on your own. So half of it is given, so it
Right.
shouldn't be that difficult.
Sometimes on the quiz it's that way. There might be just a part of the proof is there, but some statements missing or some reasons missing, and you have to fill it in. So you don't always have to do everything on your own.
Okay, so very doable.
All right. Good luck.
Good luck.